Let's have a look at 5D, question 5. This is on page 224. The question: a factory produces a large number of electric cars. A car is chosen at random from the production line as a prize in a competition. The probability that the car is blue is 0.5. The probability that the car has 5 doors is 0.3. The probability that the car is blue or has 5 doors is 0.6. Find the probability that the car chosen is not a blue car with 5 doors. Pietro solves the problem with a Venn diagram, but Maria solves it with a tree diagram. They both get the correct answer. Solve the problem both ways. Discuss and then state who used the most efficient method. Okay, let's have a look at Pietro's method. He's going to solve this problem with a Venn diagram. Okay, so what do we know? We have information up here that says that the probability the car is blue is 0.5, so we'll call this blue. That will be blue. And the probability that the car has 5 doors is 0.3, so we'll call this 5 doors here. I'll use a 5 and a D. 5D. Okay, so we know that. That represents blue car, that represents a car with 5 doors. The probability that the car has 5 doors. The probability that the car is blue or has 5 doors is 0.6. Well, that must be everything that's in the circles. Blue or 5 doors is that, this, and that. So we know that all of that equals 0.6. When you add up 0.5 and 0.3, that's 0.8. Okay, so there's obviously an intersection happening here. Remember, everything in here is 0.5, everything in here is 0.3, 0.5 and 0.3 is 0.8. Well, we know that everything in this area has to be 0.6. That's what it tells us here. So that means that must be 0.2. 0.2. And if that's 0.2, and we know that everything in B is 0.5, then we must write 0.3 here. All right. And for 5 doors, it tells us that that's 0.3, so if that's 0.2, that must be 0.1. Okay, so that's how our Venn diagram looks. We knew we had 0.6 in the circle here, so this must be 0.4 out here. That's all 0.4, because the 0.3, 0.2, and 0.1 is 0.6. All right, from there. Now let's shade in the area that the car chosen is not a blue car with 5 doors. Well, if it's not a blue car with 5 doors, it's everything but the middle. So let's shade that in. So not a blue car with 5 doors is all of this on the outside and all of this here and all of this here. And so the remaining area, the green area, is 0.8 because it's 1 minus 0.2. Let's write that here. So the probability that the car chosen is not a blue car with 5 doors, not a blue car with 5 doors, equals 1 minus 0.2. And that equals 0.8. Let's now have a look at Maria's approach. Now she solves it with a tree diagram. So I've put in the branches. Okay. Now it tells us, same information, but it tells us here that the probability that the car is blue is 0.5. So we'll start with that. If the car is blue, the probability is 0.5, so the probability of not blue is also 0.5. The other information they've got here is the probability that the car has 5 doors is 0.3. Well, let's just build this thing up. We're going to call this particular zone here, all of this, that's just looking at the color of the car. All of this, we're looking at the doors. We're talking about the doors. So this would be 5 doors. This would be not 5 doors. This would be 5 doors, and this would be not 5 doors. All right, let's look at this information. It says that the probability the car is blue or has 5 doors is 0.6. So both of those, we've got to add that, we've got to add that, and we've got to add that. Though all of those branches, that one, and that one, is 0.6. So this one here must be 0.4. All right, we'll write that in. That's 0.4. Now, if that's 0.4, then 0.5 times 0.8 equals 0.4, so that would be 0.8. If that's 0.8, that must be 0.2, right? Because that's got to equal 1. All right, now they say up here, the probability that the car has 5 doors is 0.3. So this one and that one, when we get their probabilities, they must equal 0.3. Okay, when we multiply that by that, whatever that number is, and this by that, and whatever that number is, we add them together, that should equal 0.3. Okay. Okay, so I've put the boxes down there. They're the final probabilities for each branch. Now, let's call this one here x, and this one would be 1 minus x. All right. So what do we know? We know that the probability that the car the probability that the car has 5 doors is 0.3. So let's write an equation here. So we know that 0.5 times x plus 0.5 times 0.2 equals 0.3. 0.5 times x, that's that one, that's a 5 door, plus 0.5 times 0.2 has to equal 0.3 because they told us the probability of a 5 door car is 0.3. And then we can resolve for x. So we have 0.5x plus 0.1 equals 0.3. 0.5x equals 0.3 minus 0.1. X equals 0.2 over 0.5. And x equals 0.4. When x equals 0.4, the number in this box is 0.2. When x equals 0.4, the number in this box is 0.3. This box is 0.3. And we can also fill in this box, which is 0.1. Let's go back to the original question here, and that was find the probability that the car chosen is not a blue car with 5 doors. Well, it says that it's not a blue car with 5 doors. Well, this branch is a blue car with 5 doors, and that's 0.2. So not a blue car with 5 doors would be 0.8. Okay, just 1 minus 0.2. Or you can just add up these ones. These are the other ones here, the other probabilities, 0.3, 0.4, 0.8. Okay, so if we wanted to find the probability that the car chosen is not a blue car with 5 doors, probability that it's not a blue car with 5 doors equals 1 minus 0.2 equals 0.8, which is the same answer that Pietro got.